In this video, you're gonna learn about the Newton's laws of force or laws of motion. Newton's laws or laws of motion. So here you're gonna see three different laws of Newton based on the forces. The first law states that any object will remain in the state of rest or of uniform motion until an external force is applied to it, or external force acts on the object. So here what does they say? Okay, suppose if you are moving in a uniform speed, you are just moving in a uniform speed, and suddenly an object, you can just take an example of dog. Okay, suddenly a dog comes in between. Dog comes in between. So what you will do? You will just apply the brake, isn't it? You will apply the brake. Here the brake is an external force which makes the vehicle to slow down. Or we can take another example. When you just travel, and if you just leave the acceleration, what happens? The vehicle still continues to move with the same speed, but in the later stages the vehicle slows down because another force is acted on it. So what force is acting on it? Frictional force, that is towards the vehicle and the surface or the earth or the road. Okay, so here any object will be continuing or will be in the state of rest or of uniform motion until an external force is applied to it. So usually when an object is continuing in the same state, or if the object is in same state, which means it can be at rest or of uniform motion, anything, that concept or that property is called as a inertia. That is called as a inertia. So inertia is a property. Inertia is a property where the object will be at rest or of uniform motion. So that is what inertia is. Okay. And this Newton's first law is also called as law of inertia. It can be called as Newton's first law of motion or law of inertia. So now we have just studied what is Newton's first law and what is it called, as well as the definition of inertia. So now we'll just see what is the applications, or where can we see this Newton's first law. So they have given some example. When a straight moving bus suddenly stops down, the passengers sitting inside fall in the forward direction. So now while the bus is moving, you will be in a relaxed position. Suddenly if the brake is applied, what happens? You will be no more in the state of rest. You will just try to move in the forward direction, which means there is a change in the position or change in the state of you, which means there you could see the Newton's first law. Okay, unless the brake is applied, you were in a relaxed position, but when the brake is applied, what happens? You are no more in the same position. And next we can just take the example of the football. So until you kick the football, the ball will not move. Yes? And there is one example which I can say. Okay. So usually even you would have heard that example. The book will be in dust or at rest until exams are nearby. Actually, this is a funny statement, but actually it is the fact. That is, usually students won't, most of the students won't touch the book unless there is exams nearby. Till that, the books will be at rest. When the exams are nearby, they'll just start using they'll just start reading the books or they used to study what is the content inside the book. Okay. So these are the applications where you could see in the real life, day-to-day life. And here we're going to see the another concept, that is inertia, and just like inertia, we're going to see another concept, that is momentum. So what is this momentum? So momentum is nothing but it is a product of mass and velocity. It is a product of mass and velocity, which means what is the mass of the object as well as how fast it can move. Just it actually indicates the object, either the moving object or the object at rest. So it includes both. And the SI unit of momentum is nothing but kilogram or kg meter per second. So kg meter per second. Now momentum. So here, since we are talking about the velocity, here we'll be having two velocities. So what is this two velocities? It's nothing but initial velocity and final velocity. Or in other words, we can just say change in momentum. So when there is a change in velocity, when there is a change in velocity, we can just say that there is a change in the momentum, because the momentum is what? Product of mass and velocity. Okay. So what is this change in momentum? It is defined as the difference between final momentum and initial momentum. So final momentum and initial momentum. So final momentum and initial momentum. So we just consider, we just take one object. Okay, so we just take one object, or we can just take the football. So initially, until we kick the ball, what happens? The velocity is 0. That is, the initial velocity is 0. And the mass of the ball is what? Say, we can just take 5 kg. The football weight of the mass, we can just take it as 5 kg. When I kick the ball, the velocity changes from 0 to what? 0 to some velocity. We can just take 20 or 30 kilo meter or 30 or 40 meter per second. Now, what happens to the mass? Of course, we know mass will not change. So the mass will be same, but there is a change in the velocity. Suppose if I just express this in a mathematical form, we can just say that the change in the momentum is final momentum minus initial momentum, which is the final momentum, we can just call it as mass into velocity, that is m into v, and the initial momentum we can just call it as m into u. So the change in the momentum is expressed as mv minus mu, or in simple words, m into v minus u. Now we'll just see what is the rate of change of momentum. So when there is a word rate, which means we are just calculating it with respect to time. So the rate at which the momentum of an object is changing is known as rate of change of momentum. So the below expression denotes how we can express the rate of change of momentum. So mv minus mu, the whole thing divided by t, which is m into v minus u by t. So here, if we are talking about the one object, what if we have two objects? What if we have two objects? Just like the rifle, the bullet and the rifle. So usually when we or you could observe that whenever a policeman or any cops, if they just fire, what happens? The pistol or the rifle will move backwards, a little backwards while firing, and the bullet moves forward while the rifle or the pistol moves little backwards. So there you could see two objects, that is the bullet is one object and the rifle is another object. So there we have two objects and both experiences a momentum. So how we are gonna explain this is by using Newton's second law as well as the third law. So in the next session we'll be dealing with the Newton's second law. Thank you.